Good morning, students. Today we are going to see the pressure changes during respiration. Pressure changes. There are three pressures you have to remember. One is the intrapleural pressure. That is the pressure between the pleura, pressure in the pleural space, and it is always negative. The normal value is -2 to -6 millimeter of mercury. -2 to -6 millimeter of mercury. That means it is -2 relative to the atmospheric pressure. Say if the atmospheric pressure is 760, it is 760 -2, that is 758. So this way you have to take it. And intrapulmonary pressure, it is a pressure inside the lung. It is also called alveolar pressure. And the third is the transpulmonary pressure. Transpulmonary pressure is derived by subtracting the pleural pressure from the pulmonary pressure. So it's a difference between the pleural pressure and the pulmonary pressure, and it is derived by subtracting the pleural pressure from the pulmonary pressure. So this intrapulmonary is also called as intra-alveolar pressure. Now how it is changing during the respiration? This can be represented by a graph. Take in y-axis, take the pressure. The pressure is expressed in millimeter of mercury. Then in x-axis you take time. So this is 0. So 0 in the sense it is equal to atmospheric pressure, that is 760 millimeter of mercury. And here the down it is in minus scaling, -1, -2 millimeter and -6 millimeter, -6 millimeter. And here it is +1, +2. Now we'll start with the intrapleural pressure. And the time you divide into inspiration and expiration. Inspiration and expiration. This is inspiration and this is expiration. So what happens to the intrapleural pressure? The intrapleural pressure starts from the beginning of inspiration. This is the beginning of inspiration and this is the end of inspiration, or beginning of expiration, and this is the end of expiration. Now the intrapleural pressure starts from -2 millimeter of mercury and it reaches a maximum negativity of -6 at the end of inspiration. Again it starts from -6 millimeter of mercury at the peak of inspiration and it reaches -2 millimeter of mercury at the end of expiration. So the intrapleural pressure becomes more negative, and this more negativity of the intrapleural pressure is making the lung to expand. Okay, when it is become more negative, when this factor is becoming more negative, automatically the transpulmonary pressure will be increasing. When transpulmonary pressure is increasing, it leads to more expansion of the lung. Okay. Next is the intrapulmonary pressure. The intrapulmonary pressure is at resting state, that is before the beginning of inspiration. It is equal to atmospheric pressure, that is 760 millimeter of mercury. In graph we make it as 0. So at the resting it goes to -1 millimeter of mercury, become less than the atmospheric at the middle of inspiration. Then it reaches again to the atmospheric pressure at the end of inspiration. Then it again goes to +1 millimeter of mercury and it comes back to 0 or equal to atmospheric pressure at the end of expiration. So in the middle of inspiration, since it became going to negative, it is going for negative, there is a fall, and this fall makes the air to pulled into the lung, and this +1 makes the air to push out of the lung. So this is a change in the intrapulmonary pressure, and this is the change in the intrapleural pressure. And how to represent graphically the transpulmonary pressure? It is the shaded area. So this area represents the transpulmonary pressure. Now how the events takes place? So when the respiratory center send the signals, the chest wall expands. So when the chest wall expands, The first pressure to become more negative is the intrapleural pressure. Now this intrapleural pressure becomes more negative, and because of this negativity, what happens? The transpulmonary pressure started increasing because the pleural pressures became more negative. So it is a difference between pulmonary and the pleural pressure. So this values become more negative, and because of this, the transpulmonary pressure value is be increasing. So this transpulmonary pressure is a measure of the elasticity of the lung, and when it is increasing, the lung expands. When the lung expands, the intrapulmonary pressure started falling. So when there is a fall in intrapulmonary pressure, automatically air will be pulled in and the inflation of the alveoli takes place. So this is the sequence starting with intrapleural pressure, then transpulmonary pressure, then the intrapulmonary pressure. So this makes the inspiration to occur, and the reverse takes place in expiration. In expiration, the intrapleural pressure, the negativity started reducing. It goes to minus 2 millimeter, and this makes the transpulmonary pressure will be decreasing, and this causes the intrapulmonary pressure to become positive and air will be pushed out of the lung. So the take home message is there are three pressures: intrapleural pressure, intrapulmonary pressure, transpulmonary pressure, and the intrapleural pressure is always negative. From minus 2 it goes to minus 6 at the end, again come back to minus 2. The intrapulmonary pressure becomes minus 1 millimeter related to atmospheric at the middle of inspiration and plus 1 millimeter at the middle of expiration. So this negative of the intrapulmonary pressure causes air to pull in, and this positive makes air to push out. And the transpulmonary pressure is nothing but the difference between pulmonary and pleural pressure. It is derived by subtracting the pleural pressure from the pulmonary pressure. Thank you.